Area of a triangle. By now you should know the formula for area of a triangle. Area is equal to 1/2 base times height. That shouldn't be anything new. So we should be able to solve a problem like this one on the screen. Area is equal to 1/2 base times height. Now, anytime you do an area problem, you are always going to start by writing out the formula. So area is equal to 1/2 times base times height, where we can now plug in what we know. We know that the area is equal to 1/2. The base of this particular triangle is 12 inches. So 1/2 of 12 times the height. Well, the height is 8 inches. Now, this isn't one of my favorite images, but it does give us an opportunity to talk about this particular image. We know the altitude of the high triangle by looking for one thing. And really what should always be on this triangle is that right angle mark, because that right angle mark indicates that we have a line that is perpendicular to the base going up to the vertex point of the top of the triangle, and thus it is the altitude. Without that right angle, we really don't know if that's the altitude. Now, you tend to see a lot of triangles without the right angle, but the further you advance in your math knowledge, the more I'm going to try to make sure that you are technically correct. So the height of this particular triangle is now 8. And so we can clean this problem up. 1/2 of 12 is 6 times 8 is 48. So the area is equal to 48 inches squared. And that brings us on to the next problem. Next we have, again, area is equal to 1/2 base times height. And so my area is going to be equal to 1/2 the base of my triangle, which is 13, times the height of my triangle, which is 17. Now, these are not numbers that most of us can do simply in our heads, so we want to multiply 13 times 17, and that ends up with 221. So the area is equal to 221 in my numerator, 2 times 1 times 1 in my denominator. So the area is equal to 221 over 2. And that, for purposes of these types of problems, we can simplify. Area is equal to 110.5 centimeters squared. Area of a trapezoid. Now you'll notice I've given you a formula on the screen. Yes, you could break many of these images down into smaller parts and solve for their area. No, I don't want you doing that. It's about time for you to learn the area of a trapezoid formula. So the area of a trapezoid, area is equal to 1/2 h represents the height. B1, so we have B subscript 1 represents one of the bases, plus B subscript 2 represents a second base. Now, it's important for us to understand what our base is, because we've got lots of sides to our particular shape. Bases are opposite ends that are parallel. So if we're looking at our first image over here, I've got a line on the top and I've got a line on the bottom that are parallel to each other. Those are my opposite ends of the shape and are parallel. So they would qualify as bases. So again, we're going to start with our formula. Area is equal to 1/2 times the height times B1 plus B2. Part of us retaining that formula to memory is writing it down several times. So if you write it down each time you use it, that will help. So area is equal to 1/2 times the height. Well, again, we've got an altitude that's not marked. It should be. So I'm going to go ahead and mark it there. 1/2 of the height, which is 7, times the base 1, which is one of my bases, plus the base 2, which is my other base. Let's clean this up a little bit. Area is equal to 1/2. I'm not going to take 1/2 of 7 because that's going to give me a decimal of 24 plus 10 is 34. Well, 34 is easy to take half of. That ends up with 17. And since multiplication is commutative, we can say 1/2 of 34. So our area is equal to 7 times 17, which gives us a total area of 119 inches squared, miles squared, yards squared. We don't know. We weren't told. So in this case, it's just going to be units squared. Next problem. Area is equal to 1/2 the height times B1 plus B2. All right, so our area is equal to 1/2, and our height, the distance between the two bases, so we want to first identify our bases. But is our height 4 or is our height 5? Both of them connect from the one base to another. Well, our height is the altitude, and remember the altitude is distinguished by a perpendicular line into the base. The only line that's perpendicular into the base is our 4-meter line. So 1/2 times 4 times our B1, which is 8, plus our B2, which is 5. So we can clean this up a little bit. Area is equal to 1/2 of 4, which is 2, times 8 plus 5, which is 13. So my area is equal to 26 meters squared. And now we get used to using the formula. We get used to plugging in what we know. And this is just going to make solving problems so much easier as we work through the rest of the 8th grade content. Just get used to using a formula and plugging in what we know. Area of a kite. Area of a kite uses the formula 1/2 times diagonal 1 times diagonal 2. And so we need to talk about these diagonals for just a minute. The diagonal is the point from vertice to vertice. So on this particular image, we are given that half of the distance from the vertice to the center is 3. The other half of the distance is 3. So the entire diagonal 1 would be 6. So let's start with our formula. Area equals 1/2 D1 times D2. And we're going to plug in what we know. Area is equal to 1/2 of my diagonal 1, which we said was 3 plus 3. So 6. Times my diagonal 2, which is 4 plus 9. So we're going to clean this up a little bit. 1/2 of 6 is 3. Times 13 should give us 39. So the area is equal to 39 meters squared. That wasn't too bad. Again, it's just using a formula. The more times we write the formula out, the simpler it will be. So, next problem. Area is equal to 1/2 D1 times D2. All right. Well, in this problem, we're told that the length of this section, which extends from here all the way down to here, is 2.2. Well, that's here all the way down to here, which is 2.2. That's the entire diagonal. So they've already gone ahead and added up the sections for us. So area is equal to 1/2 times diagonal 1, which is 2.2, times diagonal 2, which is 8. And since I can do 1/2 of 8 very quickly in my head, or 1/2 of 2.2 very quickly in my head, we can do either. Let's go ahead and do the 2.2. That's going to give us 1.1, which we multiply times 8 gives us 8.8. So my area is equal to 8.8 meters squared. Area of special parallelograms. This is going to be mostly focusing on a variety of shapes. So let's talk about parallelogram. What defines a parallelogram? A parallelogram has opposite sides that are parallel. And now you've seen these since 4th and 5th grade. Where's my pen? All right. So notice that the opposite sides are parallel. Since the opposite sides are parallel, they are also congruent. You'll get into more of that when you get into geometry your freshman year of high school. Now, one of the other things you'll put together is that the opposite corners are congruent. And so all of that information will continue to help you, especially as we move through this course. It'll make things simpler, but you'll use it a lot in geometry. So we can move from there to a rectangle. A rectangle is a parallelogram. Notice that its opposite sides are congruent. Its opposite corners are congruent. And its opposite sides are parallel. A rhombus. Well, I have the formula out next to the rhombus. It should look familiar. Formula for a rhombus is the same as that of a kite. Well, that's because a kite essentially is a rhombus. Not quite, but very similar. So a rhombus is a parallelogram that has 4 congruent sides. 4 congruent sides. Now, the difference between a rhombus and a rectangle is notated in the angles. It does not necessarily have 4 congruent angles. And then a square. A square is both a rhombus and a rectangle and a parallelogram. So it qualifies as a rectangle because it is a parallelogram that has 4 right angles. It qualifies as a rhombus because it is a parallelogram that has 4 congruent sides. It qualifies as a parallelogram because it is a quadrilateral that has opposite sides that are parallel. Now you remember the formulas for all of those. It would be a good idea to write down all of these examples and their formulas so that as you use them to practice this week, you are familiar with them.